Hokie dokie. In this problem, they say a certain blood test accurately indicates the presence of a disease 90% of the time when the disease is actually present. The test indicates the presence of a disease 0.2% of the time when the disease is not present. And if 3% of the population has the disease, what percentage of the total population will test negative? All right, so to go about any of these types of problems, what I like to do is make a little tree diagram sort of thing just to organize all this information. So the thing I start with is the percentage of the population that have the disease versus the percentage that do not actually have the disease. So they tell us if 3% of the population actually has the disease, then we put 0.03 here to represent, 3% of the population. And if 3% of the population have the disease, then the remaining 97% of the population do not have the disease for a total of 100% of the population, right? Okay, so now they say the test will indicate the presence of the disease 90% of the time when the disease is actually present, right? So 90% of the time, if you actually have the disease, it'll show up as positive on your, test. So you will be truly positively tested for the disease. I don't know. This is a true positive because you have the disease and you tested positive. So if you have the disease and it'll show that you have the disease 90% of the time, then that means naturally, if you have the disease, it will not show you that you had the disease 10% of the time, which is not good. So that is a false negative. Okay, now let's do the other side. They say the test indicates the presence of the disease 0.2% of the time when the disease is not present. So of the people that do not have the disease, 0.2% of them will test positively. So 0.2%. 0.2% looks like that, but as a decimal, moving the decimal back 2 places, it's going to be 0.002. So 0.002 or like times 97% will test positively. So this is a false positive. And then if 0.002 are going to test positive of the people that do not have the disease, then that means 0.998, the leftovers, will test negatively. So truly negatively. Again, this plus that equals 1, or 0.2% plus 99.8% equals 100%. All right, so now what are they actually asking for? What percentage will test negative? So what percentage will test negative? We have this negative and we have this negative. Now, we're not just going to take these decimals. We do want to take these paths, but like this path and I'm stupid. Oh no, that's right. Sorry. I'm drawing a blank here. Sorry. These are the two negatives. But what we're going to do is use these paths. So by the paths, what I mean is we are going to multiply 0.03 by 0.10, and then 0.97, multiply that by 0.998, and then add up those two products. So it's because if there's 0.03 of the population, or 3% of the population that have the disease, then 10% of those people will test negatively. And then of the 97% of the population that do not have the disease, 99.8% of them will also test negative. So you add up all these, true negative, or just like all the negative test results. Okay, let's use Siri. What is 0.03 times 0.1 plus 0.97 times 0.998? Dang, I was hoping she would say it to me. All right, it is 0.971, and as a percentage, that's 97.1 or 10%. 97.106, I'll take that. Break out the eraser to see that 8 is our answer. So I'm going to leave it at that for this first one. In the next video, I will work out 3 more examples much faster. All right, hope this makes sense. If you have any questions, let me know.